Good morning, afternoon, evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we will be talking about, or continue talking about, rational expressions. And today we're going to talk about the first step before we start adding and subtracting rational expressions. And we're talking about the LCD. The LCD is the least common denominator. Now, I'm sure you remember the LCD when we were talking about regular fractions, when you were in, middle school, elementary, when you were adding things like 1/5 plus, let's say, 2/3. And in order to add 1/5 and 2/3, you had to find the least common denominator between 3 and 5. And the least common denominator in this case would have been 15. Well, it's the same kind of concept, but now we're going to start learning how to find least common denominators between expressions, okay? It's very similar, okay? If you remember to find the LCD between numbers, you would list out their common factors. And if they didn't have any common factors, for example here, or I'm sorry, you would list out their common multiples. And in this case, let's say you didn't know that it was 15, you could just multiply the two numbers. So worst case scenario, if you didn't know that the LCD between 5 and 3 was 15, you would multiply the two together. 3 times 5 was 15, and that was your LCD. Keep that in mind, okay? Worst case, you can find common denominators by multiplying the two factors. So keep that in mind. In order to add and subtract rational expressions, you must find the LCD, though. Okay, so all we're going to do today is just learn how to find the LCD. That's it. That's all we're going to find. That's all we're going to be worried about, is finding the LCD. That's it. That's all we're going to be focused on. All right? So you got to know this, and you got to know it very well. If you don't know how to find the LCD, you will not be able to add and subtract rational expressions. So that's why we're going to take our time. We're going to work with this step by step. So to find the LCD of several rational expressions, follow these steps. Number 1, factor all of the expressions in the denominator completely. So again, guys, if you don't know how to factor, it's going to hurt you. Number 2, the LCD is the product of the common factors raised to the greatest power times the non-common factors. That is what the LCD will be. That is what the LCD will be. So you factor all of the expressions in the denominator completely, all the way, guys. And then number 2, the LCD is the product of the common factors raised to the greatest power, we'll see examples, times the non-common factors. Now, when you're finding the LCD, do not multiply them completely. Leave the factors next to each other, but do not go ahead and multiply completely. What I mean by that is if one factor is x plus 5, the other factor is x minus 2, that's your LCD. Do not go ahead and FOIL those out. If you FOIL them out, it's going to complicate your life later on, I promise you. So if those are your factored out denominators, those are the factors that you're going to multiply together to find your LCD. That's your LCD. Leave it like that. Do not, I repeat, do not, I repeat, do not FOIL them and find one trinomial. Leave your LCD as products of different polynomials. Okay? And that's it. That's literally the lesson. Now it's just putting it into practice and actually finding LCDs today. Let's actually see if we could do it. Number 1, let's just say that these were denominators. Let's find the LCM. Let's just least common multiple. If they're in the denominator, then they're called the LCD, least common denominator. Okay. In this particular case, we got to factor as much as we can. So this is a monomial already, so that we cannot factor anymore. That's just 12x squared y. But this trinomial we can factor. What times what is 1, but when added together is 2? X plus 1, x plus 1. Excellent, gentlemen. This is a monomial, so I can't do anything else with that. Xy cubed. And what times what is 4, but when added together is 5? X plus 4 and x plus 1. Excellent. Okay. Now, here comes the fun part. We have monomials here, and we have binomials here. Let's go monomials first, and let's go number to number first. What's the LCD or LCM between 12 and 18? Okay, 6 is a factor. Factors are numbers that are less than or equal to the number. Multiples are numbers that are greater than or equal to the number. So what's the least common multiple between 12 and 18? 36. So that's it for the number. We're done. For the variable, the least common multiple of a variable belongs to the largest exponent. So what's the least common multiple between x squared and x? X squared. The least common multiple for variables belongs to the largest exponent of that variable. What's the least common multiple between y and y cubed? Y cubed, okay. So we're going to stop right there. Does everyone see how we got the LCM or the LCD? It's the same thing. It's just LCM is when it's in the numerator. LCD is when it's in the denominator. Does everyone see how we got the LCM for the monomials here? Everyone understand this? Okay, now for the binomials. Check it out, please. How many x plus 1s do I have here? 2. How many do I have here? 1. What's the highest exponent? I have x plus 1 squared here, and I have an x plus 1 here. So what's the LCM when we're talking about x plus 1s? X plus 1 squared, because I have 2 of them in one denominator. And then I have an x plus 4, correct? Which I also need as my LCM, and that is my LCM of this expression. That's my LCM. If that was in a denominator, that would be called my LCD. It's the same exact skill. It doesn't matter if it's in the numerator or the denominator. It's the same exact skill. So it's a matter of finding what is common to both denominators. This is all we're going to do today is practice. Does this make sense, gentlemen? Promise? Okay, let's continue. Number 2. Let's factor. What can I factor out of this guy? Very good. So I've got x plus 2. And here, kick out a negative 3. Excellent. And a positive 2. Excellent. Okay, so what's my LCM? Very good. I've got a 2, so I need a 2 there. And then I have an x plus 2. And no, not squared. I have 1x plus 2 here. I got 1x plus 2 here. I don't have 2 in either one of them. If I had 2x plus 2 here, then it would be squared. But I only have 1 in both, so I only have 1 in my LCM. And then I also have an x minus 3, right? So an x minus 3 is also part of my LCM. Does that make sense? You with me here, my brothers? Talk to me, guys. This is the part of the lesson that you need to talk to me. Because I'm here. I'm with you now. Yes, sir, my brother. Oh, I thought you had a question, my man. May I continue, gentlemen? Okay. How about this guy? All right. Let's factor all of these guys. This right here, what does it factor out to? X minus 1 and x plus 4. Beautiful. Well done, gentlemen. How about this bad boy right here? X plus 4, x minus 2. Thank you, gentlemen. Beautiful. And how about this bad boy? Okay, x minus 2, x minus 2. Excellent. Okay. So, my LCM here. What's my LCM going to be? What's my least common multiple? Well, let's start one at a time. I got an x minus 1 here. So I need an x minus 1 in all of them. Perfect. I got an x plus 4 here. Right? I need an x plus 4 in all of them. Okay. Now, that's done there. I got an x plus 4 here. I already accounted for that one. I got an x minus 2 here. But I got two x minus 2s here. So I have an x minus 2 squared that I need. Am I missing anything else here, guys? That's my LCM. Do you see the way I went through it? Do you see the logic I used? Can you use that logic on your own? Does it make sense? Because I know that when I'm here up front here doing it, it's nice and easy because I'm going through the logic. But guys, the whole point of me teaching you this is for you to understand the logic that I'm using. Not just for you to copy what I'm doing, but for you to understand, hey, why did Mr. Morrow say that? Why did he ask these questions? What questions did he ask? Why did he do that? Does this make sense, my brothers? Yes, sir. Thank you for asking. He said, I don't understand why he did the x minus 2 squared. Okay. I know that I have an x minus 2 factor that I have to use as one of the multiples, right? But don't I have two x minus 2s here? So that means that I need two that I need two x minus 2s. My LCM is always belonging to the highest power. Isn't x minus 2 times x minus 2, isn't that an x minus 2 squared? So I need a squared as my multiple. Because I have two x minus 2s. Under one denominator, I have two x minus 2s. So I need 2 as my LCMs. Thank you so much for your honesty. See what happens when you ask? Thank you, my brother. God bless you. Good man. May I continue, my brothers? Thank you. Next. Now we get to the good stuff. Now let's see how this would work. We're not going to add them yet. We're not doing anything yet until we get this down perfect. We're just finding the LCD right now. So my LCD, first we're going to deal with the numbers. What's the LCD between 15 and 18? 90. Wow. Good job. Now, for anyone that doesn't know how he got that, you go back in time to when you were in middle school and you break this down. This is 3 times 5. This is 3 times 6. This is 3 times 2. Okay? Your GCF, a 3 and a 3 comes out as a 3. Your LCM is your GCF of 3 times the leftovers. So a 5 and a 2, that's 10, times a 3. So 3 times 3 is 9, times 10, that is 90. Beautiful job, son. So I got 90 times. You have an x and an x cubed. So my LCM is x cubed because you go to your highest exponent. You got a y squared and a y, so it's y squared. So my LCD is 90x cubed y squared. Good job, son. Way to go. That's my LCD. This is just the first step in being able to add or subtract rational expressions. Because after this step, then we start converting the denominators so we can have common denominators. But before we can convert the denominators, we got to know what we're converting them to. Number 5, I want the LCD. Okay, we got our first factor. So we break this guy down into x minus 2, x plus 1. This guy we break down into x plus 1 and x plus 1. So what's my LCD? You got an x minus 2 and an x plus 1 squared. Very good. That's my LCD. I have an x minus 2 that I need as the LCD. And I got an x plus 1 squared. Why squared? Because in one denominator, I have 2x plus 1s. And my LCD belongs to the highest exponent polynomial. This makes sense, boys? Are you sure, my brothers? Okay. Find the LCD here. Okay. First things first. What happens here? Very good. You got to factor out a negative here. So let's have a rewrite here. This is 1 over x squared minus 25. But I'm going to factor out a negative 2 here. So actually, first I'm going to factor out a negative first. So this becomes a negative 9 up here. And then this becomes a 2x minus 10. Now, this denominator becomes x plus 5, x minus 5. This denominator becomes 2 times x minus 5. Now, what's my LCD? You got a 2, x minus 5, x plus 5. Very beautiful. Well done. That's my LCD. Yes, sir, my brother. Yes, sir. I took out a negative 1 from here, my brother, and I brought it up here. That's why it became a negative up there. Well, I just took out a negative first. If I take out a negative, this 2 becomes a positive, right? And this 10 became a negative. Yes, sir. No, you have to. You could have taken out a negative 2 to begin with, but if you take out a negative 2, you may confuse the fact that this negative came up here. Got to be careful with that negative. Yes, sir. You sure, my brother? Okay. Thank you, my man. May I continue, my brothers? Sure. Okay. Now, forming equivalent rational expressions. This is the next step. After you found the LCD, now we got to form an equivalent expression. So, you rewrite each denominator in factored form. You find the LCD, and then you rewrite the equivalent rational expression using the LCD by multiplying the missing factors to both the numerator and denominator. So once you find the LCD, you have to ask yourself, okay, what do I need to multiply to this denominator and numerator to make this fraction have the same the same denominator as my LCD? And I need to multiply to both the numerator and the denominator so that I can have an equivalent rational expression. Why would it be equivalent, Mr. Morrow, if you're multiplying stuff? Well, as long as I'm multiplying the same value to the numerator and the denominator, what is the value of anything divided by itself, guys? 1. So I'm not changing the value, I'm changing the appearance. What is this crazy man talking about? Let me show you. I factor this right here, I got x plus 2 and x plus 1. I factor this down here, I got x plus 2, x minus 2. My LCD. My LCD here is going to be x plus 2, x minus 2, and x plus 1. Does everyone see that? You promise? Okay. So here I've got 4 over x plus 2, x plus 1, and I've got 9 over x plus 2, x minus 2. Now, here's the step right before we add and subtract. You have my word of honor. I'm not going to make you add and subtract yet, but I am going to make you do the step right before you add and subtract. I need to convert these so that they have common denominators before I add and subtract. So my brothers, what do I need to multiply to this denominator to make it look like this LCD? Thank you. So I need to multiply an x minus 2 to both numerator and denominator. So this becomes 4x minus 8 over x plus 2, x plus 1, x minus 2. What do I need to multiply to this denominator to make it look like this LCD, my brothers? On x plus 1. So this becomes 9x plus 9 over x plus 2 times x minus 2 times x plus 1. Now, guys, if I had said to add or subtract these, now I would just simply add the numerators together, keep the same denominator, and then I can simplify from there. But that's the next step for the next lesson. You have my word of honor. All I want you to know for this lesson is how to find the LCD and how to convert your fractions so that you can, in the next lesson, start adding and subtracting from there. If you think about it, this isn't that bad. It's factoring, which you know how to do, LCD, which isn't that bad, and then multiplying polynomials. What's up, my brother?
Can you explain real quick why you multiplied the first fraction by x minus 2?
Of course. What was this denominator missing in order to look like this LCD, Papa? It was missing the LCD, the x minus 2. What was this missing, my brother, in order to look like the LCD? It was missing the x plus 1. So whatever the LCD is missing, that's what I'm going to multiply to the numerator and denominator. Fantastic question. Thank you. Yes, sir, my brother. If I wanted the undefined values, which I will not ask, you would find that before. Yes, sir. Thank you, my brother. How about for this bad boy here? What's the LCD here, my brothers? What's the LCD between 6 and 20, my brothers? 30. Very good. No, actually, yeah, no, 30 is not a multiple of 20. It'd be 60. And then what about the variables? A squared and b cubed. Okay. What do I need to multiply to 6a squared b to get to this LCD? 10b squared. So this would become 30b squared over 60a squared b cubed. What do I need to multiply to this denominator to get to 60a squared b cubed? On negative 12, you need to multiply on a, and that's it. So then I would have 60a. Oh, I'm sorry, it's 3. You're right. It's negative 3. Good. 3a. So this would be 15, sorry. 15a, yeah, over negative 60. No, I'm sorry. Why would it be negative? Sorry, I was looking at the 5. My bad. So that's negative 15 over 60 a squared b cubed. Are you guys with me here? Yes, I'm with you. I made a mistake. My bad. I was looking at the negative 5. But you're right. I got to pay attention. I got to practice what I preach. Thank you, sir. I got to practice what I preach. All right. Next, find the LCD and then rewrite each rational expression with the LCD. So here I got x minus 5, x plus 1. Here I got x, x minus 5, x minus 2. What's my LCD? X plus 1, x minus 5, x minus 2. Okay. What do I need to multiply to this first guy to get my LCD? On x minus 2. So I will be left with 5x minus 10 over x minus 5, x plus 1, x minus 2. What do I need to multiply to this guy to get my LCD? X plus 1. So I'm left with negative 3x minus 3 over x minus 5 times x minus 2 times x plus 1. Are you guys seeing this? Promise? Okay, real quick, this last one. They want you to rewrite 3 over 4p squared minus 8p with a denominator of 16p cubed minus times p minus 2. I know you guys want to go to lunch. I'll finish this on my own. If you want to stay, you can. If not, have a great day. God bless you. So in this particular case, you're going to first factor. So I'm going to factor out of 4p, and I have p minus 2 left over. Now, I want to get the denominator 6p cubed times p minus 2. So basically, I have to ask myself, what do I have to multiply to 4p times p minus 2 to get the 16p cubed? Well, I'm going to have to multiply a 4p squared. So I'm going to multiply a 4p squared up here. So my answer would be 12p squared over 16p cubed times p minus 2.
Sir,
Yes, sir.
how come the 4p squared wouldn't get distributed to p minus 2?
Okay, because remember what I said. You never want to distribute the denominator. You want to leave the denominator as a product of its factors. Correct. You always want to distribute the numerator, for sure you distribute. But the denominator you leave as a product of its factors. Thank you so very much, guys. I hope you learned a lot. Have a wonderful day. May God bless you all. Thank you, thank you, thank you. Bye-bye.